we are discussing on 10th standard SLC mathematics, the last chapter, which is polyhedra and networks. First, I'll just give you a glimpse of the book, SLC book, what it has to say on this chapter, and then I'll go ahead and try to explain to you in a better way. If you want to read more, just pause, just press pause, and you can read this thing slowly. A line is generally formed by joining 2 points, and whereas a triangle is formed by joining 3 points. Similarly, a quadrilateral like square or anything etc. is formed by joining 4 points, and a polygon, it can be anything more than 3 points. When a triangle is a polygon, 3, 4, 5 or more. A regular polygon is one which has all the sides are equal. Now since we have been discussing only about two-dimensional objects, now let's go into 3D. All of you would have seen some 3D movies recently. They were very famous in Kannada and in Hindi and in English. When we see a 3D movie with goggles on, it gives a different effect altogether. Yeah, we have been discussing about surfaces which are 2D in shape. Now let us talk about 3D figures, and in that our Swiss mathematician Mr. EULER worked on polyhedron. Polyhedron is just a cube. You would have played games with cube, and then you can understand more better. Now let us go back to the textbook, what the textbook has to say about this. Most important thing is the Euler's formula, which is F plus V is equal to E plus 2. That is faces plus vertices is equal to edges plus 2. Now what's a face, what's a edge, what's a vertex or vertices? If you can see, face is one side of a cube, is called as face. Vertex or vertices is a corner point. It is a corner point. Edge is the line connecting in the corner of the faces. The most famous polyhedron are tetrahedron, cube or hexahedron, octahedron, dodecahedron and icosahedron. This is depending on how many faces and vertices and edges they have. A tetrahedron has 4 faces, that is 1, 2, 3 are seen over here and 1 behind. It has 4 vertices, 1, 2, 3 and 4. It has 6 edges, that is 1, 2 and 3 over here and 4, 5 and 6 over here. Similarly, a cube or hexahedron has 6 faces, as you can see inside here and bottom, that is top and bottom became 2. Similarly, this side and this side became 2, and this side and this side became 6 faces. It has 8 vertices. You can see it here, 1 2 3 4 and 4 on the upper side. It has 12 edges, that is 1 2 3 4, you can see here. Similarly, 4 this side and 4 this side. It has 12 edges. Octahedron has 8 faces, that is you can see 4 over here and similarly 4 behind. 1 2 3 4 faces here and 4 behind it. It has 6 vertices. It is easily found. It has 6 vertices, that is you can see here 1 2 3 4 5 and 1 behind over here, and has 12 edges. Mostly the questions are asked only on tetrahedron, hexahedron and octahedron. Generally they are not asked on dodecahedron, but still you can just try to remember that it has 12 faces, 20 vertices and 30 edges. Similarly, this figure has 20 faces, 12 vertices and 30 edges. So when we go for the formula f plus v is equal to e plus 2, you can find that all the answers are equal. Now seeing this, what has been taught to you, you can fill this in your textbook. I've already given you f plus f, v and e. You can fill the remaining over here, f plus v and is equal to e plus 2, and try to solve the 10.1 exercise in your textbook. For any doubts, you can always call me. My number is 94490111239. Email ID is pawan@teachers.org.